the amount of excess charge on an object. In this experiment, I used two charged pieces of Scotch tape, observed the interactions between the two tapes, observed the interactions between the tape and a charged pen, between the tape and between the tape and a neutral object. I determined the excess charge on one of the pieces of tape by measuring the distance between the two pieces of tape as they repelled each other, used the mass of one of the pieces of tape to calculate the force due to gravity, calculated the charge on the piece of tape, and calculated the excess or deficiency of electrons and the electron-to-atom ratio. As a result, the tape was positively charged. The gravitational force was equal to the electrical force of tape A on tape B, and it was 0.00193 newtons. The charge on one of the pieces of tape was 6.95 times 10 to the negative 9th coulombs, and it was deficient in electrons because it was positively charged. The ratio of electrons to atoms was 1.225 times 10 to the negative 7th. In this presentation, I'll be covering the key physics principles, the experiment and setup, the conclusion, the computational model, and some what-if scenarios. The key physics principles were that charge is a property of matter, like charges repel, opposite charges attract, charged objects are attracted to neutral objects. The tape that I used was 19.7 centimeters in length and 1.8 centimeters in width. The interaction that I expected between the two tapes is that they should repel each other since they are created in a similar manner, and like charges repel. As a result, the two tapes did repel each other, and between the tape and a neutral object, I expected that the tape should be attracted to neutral objects since charged objects attract neutral objects. As a result, the tape was attracted to the fish food container I used as a neutral object. Is the tape positively or negatively charged? If it's positive, it should be attracted to a negatively charged pen. If it's negative, it should be repelled by the pen, and if it's neutral, it should be attracted to the negatively charged pen. In conclusion, the tape was attracted to the negatively charged pen, and because the two pieces of tape previously repelled each other, it can be determined that they both have charge, therefore the tape is positively charged. I suspended tape B between two neutral objects and held tape A close to tape B in order to levitate tape B. The displacement of tape B was 1.5 centimeters. I calculated the force due to gravity on tape B, and ended up with 0.00193 newtons. Because tape B was not moving, tape B was in equilibrium, and the force due to gravity is equal to the electrical force of tape A on tape B. The charge on tape B I calculated to be 6.95 times 10 to the negative 9th coulombs. I calculated the number of electrons by taking the charge and divided by the charge of an electron, and I got 4.34 times 10 to the 10th number of electrons. Because the tape is positively charged, there is a deficiency of 4.34 times 10 to the 10th electrons. For the ratio of deficient electrons to atoms, I calculated the number of atoms by taking the area of the tape and dividing by the area of an atom, and I got 3.546 times 10 to the 17th atoms. Then I calculated the ratio of electrons to atoms to be 1.225 times 10 to the negative 7th. The key assumptions I made were that charge is evenly spread on each piece of tape. Each piece of tape had the same amount of charge. The pieces of tape can be treated as point charges, with all charge concentrated at the center of the tape, and there was no air resistance acting on tape B as it was being repelled by tape A. For the computational model I made in GlowScript, I made the model to scale, but I scaled it up as a factor of 1,000 so that the point charges could be visible. The tape A is represented by the red point charge, and tape B is represented by the blue point charge. The displacement between the two is 1.5 centimeters, and the force of gravity is equal to and opposite to the electrical force, both acting on tape B. The what-if scenario is: what if the electrons were positively charged and the protons were negatively charged? The tape charge would overall be negative. The tape A and tape B interaction would still be the same because they are both like charges and they would repel. The tape and the neutral object interaction would be the same because the tape would still be attracted to neutral objects since charged objects attract neutral objects. The tape in the negatively charged pen would be different, however, and the pen would repel the tape since they are like charges. The tape was handled as little as possible because the excess charge on tape would spread to hands or neutral objects in order to make the tape neutral. Therefore, it was handled as little as possible to limit the redistribution of the charge.